Hello and welcome to Technology Connextras, the channel where I talk about stuff and don't prepare for anything. Except today, I've made a list of things to talk about. Wow. So some people suggested that it would be a good idea to explain how to calculate the break-even point on a geothermal heat pump or otherwise, and so that's what we're going to do. I also have some other thoughts that I want to bring up, and then the end. But before we start, I want to clarify that I recognize 1000% that a geothermal heat pump is not feasible for the vast majority of people. And it was also brought up that one problem that is frighteningly common is that landlords who have offshored the cost of utilities to their tenants don't give at all a care about energy efficiency because it's not their problem, which is really stupid and one of the reasons why efficiency regulations kind of need to be a thing. Because for every person who can turn the energy cost into an externality, then they're going to just take the cheapest option to keep their tenants happy. And unfortunately, it's very bad. But setting aside all those problems, just to acknowledge that these systems are very expensive upfront, I really hope that changes. One of the things that just seemed absolutely crazy to me was that some of the cost estimates that I was seeing from people seemed to indicate that the actual cost of drilling the well was only like $17,000 or $20,000, and the heat pump unit itself was another $20,000. And that to me is just ridiculous. I don't understand why the heat pump components should cost, I mean, they're going to cost more than just a general air handler and air conditioner. But I mean, like the compressors, it's the same. I mean, some of the footage I used that a patron gave me, it's the same compressor that goes into, it may be the very same model that's in the air conditioning compressor that's right outside this room. So I don't understand why the inside components should be anywhere near $20,000. Like, to me, the only really special thing is the liquid to refrigerant heat exchanger, and those exist for purposes other than just a geothermal heat pump. One use for that, which I didn't even know was a thing until I started following some HVAC people on YouTube, was if you're in a restaurant and say there are beer taps that are far from the room that the beer kegs are in. Well, there's a long line of hose between where the kegs are kept and the tap, and if you don't have a glycol system, which is basically just a loop of coolant going around these lines and back, that will warm up and you'll get cold beer at the tap all the time. So these restaurants have machines which sit somewhere and refrigerate liquid that then gets pumped around the beer lines to keep it cool. And those have the same kind of air heat exchanger that you would find in a geothermal heat pump. So I really think something, to me, and I'm a layperson in this regard, but something seems wrong about that pricing. Maybe we just don't have the economies of scale we need yet. I don't know. But what we really would like to, or I would really like to see happen, is ground source heat pump technology get a lot cheaper. And I think it will, but what I actually think is more likely to occur is that air source heat pumps will start to see COPs of maybe 2 or 3 that are attainable in well below zero conditions. So hopefully that happens, because that solves, if we can do that and the COP only dips below 2 on really, really cold days, then it may not be worth actually digging a geothermal well for most people. It would solve a lot of problems. I hope we can get there. There are thermodynamic things that are involved, but really if we manage to find a refrigerant that its boiling point at, say, 10 psi was minus 80 degrees, then I don't see why that wouldn't at least give a COP of 2, but I'm no expert. I don't claim to be. All right, how to calculate your break-even cost. So I'm only going to go over natural gas and propane because they are the only thing I have familiarity with, because once you get into like heating fuel, I have no idea how those systems work. But it's pretty straightforward to figure out what your costs are. And the first thing you need to do is to convert the cost of your heating fuel into kilowatt hours, or you need to convert however your heating fuel is billed into kilowatt hours back to cost per kilowatt hour. That doesn't sound at all sensical, but let's just go through an example. Natural gas. Here in the US, I believe this is standard across the country, but it might not be. The unit of natural gas that you are billed for is called a therm. If that sounds like a dumb made-up unit, that's because it's 100,000 BTUs, which also people have a problem with that unit, so it's great. But anyway, a therm is 100,000 BTUs, which I'm going to silence this. How about that? So a therm, which is 100,000 BTUs, is equal to 29.3 kilowatt hours. So for every therm that you're getting billed for, you're getting 29.3 kilowatt hours worth of energy as fuel. Now, how well can your heating system turn that into heat? That's going to vary. So you ideally, to get a really exact figure, will want to know the efficiency of your furnace or boiler. My furnace is 95% efficient, so for every 100 BTUs that gets delivered as a therm, every 100,000 BTUs that get delivered, 95,000 BTUs end up heating my home, 5,000 BTUs ends up outside. There's a small quibble with that, we'll get there. So the way that I came to the cost in the Chicago area, I don't have my own NICOR bill, because out here I have propane. So, so I had to use a sample NICOR bill, which I don't know how accurate these numbers really are. But that NICOR bill worked out to, the sample that I saw, 62 cents per therm. So we go back to one therm is 100,000 BTUs is 29.3 kilowatt hours. That costs 62 cents, which works out to 2.11 cents per kilowatt hour. So when you consider the loss, the small loss from a furnace, consider it as 2.25 cents per kilowatt hour. Now, electricity in the Chicago area costs just about exactly 10 cents per kilowatt hour if you're on a flat rate plan. So that means that gas costs a quarter, almost perfectly, 1/4 that of electricity for the same unit of energy being delivered to your home. So to get a heat pump to match the cost of gas, it needs to have a COP of 4. It needs to be quadrupling the amount of energy it is moving for you compared to how much it is consuming. So that's how that works. Now, as an example, here where I have propane, propane is a lot more expensive than natural gas. It's more than twice as much in this market. So my cost for propane ends up working out to 5.3 cents per kilowatt hour. So more than twice that of natural gas, at least on that sample bill. And usually it's higher than that. I just used my last bill, which was $1.39 a gallon. 1 gallon of propane is 91,330 BTUs, which is equal to 26.766 kilowatt hours. So again, it's fairly straightforward. You need to figure out you need to equate your cost per kilowatt hour of your heating fuel and then compare that to your cost of electricity. Then you'll know the COP you need to match, because if you have, say your electricity is 15 cents per kilowatt hour, well then you're never going to get a heat pump to beat the cost of gas if it's only 2.5 cents per kilowatt hour. But if your gas costs 5 cents per kilowatt hour and your electricity costs 15 cents, you only need a COP of 3 to beat that. So if you had a geothermal system and you could nearly all year get a COP of 4 or better, you would save money in the long run. But let's be real here, it's a huge upfront investment that may not make sense. That quibble I was talking about. Some people have sent me messages on Twitter that their furnace or boiler, because it seems like most of these people were in the UK, gets greater than 100% efficiency. And the reason why they're saying that is because the way efficiency is calculated there, the energy you get out of the water condensing is considered free. So that's not part of the energy of natural gas. I am pretty confident that the AFU, which is what we measure the efficiency of our heating systems, actually 100% includes that condensing energy. I'm pretty sure that's true because I've never seen a condensing furnace with an AFU over 100. Maybe they exist, but as far as I know, the highest I've ever seen is 98. So and they are condensing furnaces. So I think the AFU, which is the metric we use in the US, does consider the water vapor condensing as part of the available energy. I don't know the specifics there, but I just wanted to bring that up. Now, here's where this gets even more complicated. If you have variable rate pricing, which you may do, in fact, here I do with my electricity, then the math becomes completely different, and there are ways that you can maximize what makes more sense. Now, again, because I have propane here, and propane costs twice that of natural gas, I had not done this math or really figured this much out when I had my HVAC system replaced here. And had I done that, I would 100% figured out how to get an air source heat pump. I would have found some HVAC company to do it, because as of now, I only need to get a COP of 2 to be paying less than propane for heating. And that's attainable, quite frankly, most of the winter. There are going to be cold snaps where I can't get to COP of 2, definitely, but I would say probably only 30 days of the year would that not be possible. And the other thing is, because my electric rate is variable, that bends what that COP changeover is. So on that variable rate plan here in the winter, the electric cost is generally always lower than it would normally be. There's not much variation. When that weather event struck Texas though, oh boy, because I'm not in Texas, but the Eastern Interconnect goes almost that far south, so our energy was being shared with a lot of the region that needed more than usual. Wholesale prices got ridiculous up here. There was a time when it was like 60 cents per kilowatt hour, which is more than 6 times higher than typical. So that's the danger of wholesale pricing, but typically in the winter, it's much, much lower because most of this region has natural gas heating, so electrical demand in the winter is lower than in the summer. That may change if everybody gets heat pumps, which is important, but the other thing is you can smartly run those heat pumps depending on when generation is available. If it becomes more expensive, you can run them less. There's a whole lot of stuff you could do, especially if you do have access to both fuels, because if I know, and my cost of propane also varies depending on what the cost was when I get the tank refilled. But if I know that cost and I know what the COP is of the heat pump, then and I know the cost of the hourly rate, that can all be configured. Now that's complex, I understand that, and that's way more than most people need to be doing. So I think it makes most sense to compare it on what most people do, which is having a fixed rate for those energy costs. But I'm just giving you some more information there. And that is why a smart thermostat that was aware of all these things is actually a pretty solid investment if you can set that up, because it can literally always be optimizing for your energy cost. And hopefully one day, energy costs are tied to emissions. I went there. This is going to make some people upset, but that whole thing about how 71 companies are responsible for, or 100 companies are responsible for 71% of the emissions, they provide the fuel which we as consumers are burning. So it's kind of unfair to me to say that they are the sole reason those emissions exist. And if we are going to make it so that the lower emissions technologies cost less to run, we either need to get rid of the free externality situation that we are currently in, or we need to massively subsidize systems which are lower emissions. Because if you're going to say that the point of use is not a part of the equation, I just think that's intellectually dishonest myself. Next, I want to talk about thinking of the variability of energy availability and cost, a concept that I might make a whole video about this, so I won't discuss it at too much length, but everybody talks about energy storage. How are we going to get more batteries in more places? It's a great question. We need to answer that. But your house is a battery. You have a thermal battery at your disposal, just like a water heater is a thermal battery. It's not running all the time to keep that water hot. It just has to replenish it. One thing that I actually do here in the summer is I use the entire house as a thermal battery because I don't run the air conditioning during the day. The rates are highest during that time, and I have my thermostat programmed to basically run the air conditioner most of the night, so it sets itself to, I think it's 66 degrees. It might be 65, I'm not sure. And then that starts at 10 p.m. Then in the morning at 8 p.m., the set point goes up to 78. Now, this house has new enough windows and it's well shaded that no matter how hot it is outside, even when it's like 95 degrees, the inside temperature only rises by about 10 degrees during the day. So I am able to completely eliminate my energy need for air conditioning by overcooling at night. And that's not something that's possible for everybody because some homes are not well shaded, not as well insulated, they're older. Totally understand. But that concept of using your building as a thermal battery is something that I think is worth exploring, because say we have, especially consider renewable energy. If there's a lot of solar on the grid right now and everybody had heat pumps, turn them on, use that energy, get the building warmer, overheat by a couple degrees so that when there's less availability, that demand's not there. There's a lot of load side management we could be doing that I hope to see us start doing. Right now, I'm doing it myself because with the current energy grid, energy at night is very cheap because we have baseload capacity. We actually have a fair bit of nuclear here in Illinois that's just running all the time. So once people go to bed and all those energy sources go away or energy needs go away, the cost of energy goes very, very cheap. So for me, I'm able to take advantage of that because this building works as a thermal battery, which is great. And I wish that that concept gets a little more traction because I think it's really powerful and I don't think many people are paying much attention to it. And so to close this out, I know I started by saying this, but my intent here is not to shame people who cannot do these sorts of things, especially because there's a lot of people or a lot of situations where you, the person, are not the stakeholder. And we have, like, renting is one of those situations. If the landlord is responsible for providing equipment that functions, but they're not responsible for the ongoing operating cost of that equipment, they will always take the cheap option because that's in their best interest and they don't care that it harms their tenants. That's a problem. That's a huge problem. And we need to figure out a way to solve it because in the long run, it's going to cost everyone less money. The landlord may have a higher upfront cost for putting in the new equipment, but you can then people can more afford rent. If you have to think of it in such a cynical way, if people's energy bills go down, then that means you have a wider pool of tenants that are available to you. I kind of hate painting it that way because then it's like, oh, I can just charge $50 more for the rent. But you know, that's the sort of problem that renting has right now, is that if the human being occupying the space is not the stakeholder for that space's equipment, or I should say, that's not even right. If the occupant of the space does not own it and they don't care about its maintenance, and things get wrong really fast. And I recognize that there's millions of people in that situation and it's not their fault that their landlord sucks. So I'm not trying to put anyone down for having an inefficient furnace or whatever, because yeah, I understand it may not make any sense for you to have a better technology. It does not make sense for me to install a geothermal heat pump because the upfront cost is so high, and I have other ways to manage my energy costs that it would be a feel-good thing, not a practical thing. And there's value to that, but I'm saying right now, I'm not trying to poo-poo anybody for not embracing these technologies because I understand you need to be in a privileged position to do that. What I hope happens is that policymakers, particularly with making air conditioners reversible, they pay attention. In my opinion, there should not be an air conditioner that cannot be a heat pump. There are some subtle differences. I may have oversold the simplicity of turning an air conditioner into a heat pump. There are different things to consider, like the compressors may be slightly different. The expansion valves might be different. But I do know, because of the fact that ductless mini split systems like what I have in my garage are, you know, the cost shipped to me was about $1,000 for that. and it has a reversing valve, it has an electronic expansion valve probably, and it is a fully featured reversible heat pump. So it seems to me as though there should not be a significant price delta between a standard air conditioner, which costs a lot more than that mini split did, and an air conditioner which can go both directions. That's something that needs to be fixed. We basically need to remove the ability for unidirectional systems to exist, because especially for me with propane right now, it would be cheaper for me to run the heat pump a lot of the time. And with me having the flexible electrical rate that I do, even in the winter, if the COP is only 2, that still might cost less for me than burning propane. So that's the sort of stuff. That's why I'm making this video. I want more people to not this video, that's why I made the other one. I want more people to understand that there is a lot we could be doing with heat pump technology that we're not, and I don't know why. Anybody who's in a climate like mine, yes, you're going to need some sort of fuel to heat your home during some parts of the year. But if you have an air conditioner, why would you not also want it to be a heat pump? Some days of the year, it's going to cost you less. And if we get our butts in gear, it'll cost less because it is the cleaner option. That's where I wanted to end this, I think. Yep, bye.